So welcome everyone to this introduction to MapStruct, which is called Get Set Go. My name is Joris Kuipers. I work for Trifork Amsterdam as the CTO. I am not Java 11 certified, nor certified in anything else, but I do have 20 years of Java experience. I did actually learn a lot of new things in the previous talk, so very much thanks for that. Today I will be talking about MapStruct. MapStruct is a bin mapping tool, which basically means that it's a tool that helps you to take an object of one type and map it onto an object of a different but similar type. I chose this topic because I think it's worthwhile to know, and also because the logo matches the JFall theme perfectly, as you can see here. That's also very nice for slides. Why would you want to use something like this? Well, actually, it turns out bin mapping is a very common concern in many enterprise applications. Our main use case, by which I mean for my current project, is that we do contract-first development of APIs by writing OpenAPI specifications in YAML, and then we actually generate request and response objects from those using the OpenAPI tools generator. And we do want to use those objects just to map our JSON requests onto, or to unmarshal to JSON, but we want to map them onto our own domain objects, which are similar, obviously, but typically not exactly the same. But there are multiple other use cases, right? Maybe you want to use JPA, but you don't want to pass your entities all the way up to the entity layer. Maybe you're doing a bigger application and you want to have something like a domain-driven design anti-corruption layer. So instead of just importing types from everywhere, you want to have your own domain model and do some mapping there. That's all valid use cases. Now, when you look at the code that you need to write for something like this, it's actually trivial, right? It's typically just calling a bunch of getters and setters, or maybe doing some constructors if you're doing immutable things. Why not write that yourself? Well, first of all, it's tedious, right? It's boilerplate code. You could actually use something to generate that maybe from your IDE, but it's also very tedious to keep this code up to date, especially. So in our use case, for example, if we add a field to a response of an OpenAPI spec, and we forget to actually do anything to make sure that our domain actually can populate that thing, we don't want to be able to just forget that, leave the field null, and then simply have a running application that will never produce the new value. We actually want to get a compile time error where it says, hey, you have a generated type here that has a field, but there's no way that it can ever be populated. So that's something that MapStruct can do, obviously, because otherwise I wouldn't mention this. Now, there are various tools that can do this sort of bin mapping for Java, actually. So why would you want to use MapStruct instead of one of the other tools? I don't actually have time to cover the other tools, but MapStruct is the best one for a number of reasons. It does source code generation, first of all, and that has a lot of benefits by itself. First of all, the code that is being produced is very readable. It very much looks like the same code that you would manually write if you were doing the tedious work of writing mappers code. But also, because it's source code and it's straightforward code that's being generated, at runtime it's going to be as fast as code that you write yourself. It doesn't use reflection or anything like that. A lot of older tools like Dozer, for example, use reflection, and it's terrible. The performance is absolutely hideous. But it's also type safe, right? All of this code is actually compiled. If I try to map something from a property of type A onto an incompatible property of type B, MapStruct will actually tell me at compile time, hey, I cannot do that. It's not going to be a runtime error or anything like that. So you get very nice compiler warnings and errors about issues. That maybe, and I'll show you that. Also, there are 0 other dependencies that you introduce by adding MapStruct to your project, right? You're not getting something like, oh yeah, and there's this tiny dependency on Guava, and boom, and all of a sudden your jar file becomes 20 megabytes larger. There's 0 additional dependencies. Also, if you're wondering, because this thing is an annotation processor tool, it runs at compile time, it is also fully compatible with tools like Lombok. So if you like that for code generation, you can easily combine them. It's also a very flexible tool. You can tune how mappings actually work using annotations by writing additional code. You can mix and match that. It doesn't just support Java bean getters and setters. It supports calling constructors. It supports a number of builder patterns. It even supports mapping types with public fields. I have no idea why you would want to do that. And there is a service provider interface if you want more control. For example, to teach it about the new builder pattern that it doesn't know about yet. And there's IDE support, which is not necessary, but it is actually very nice. It's also a project that is Apache licensed, so it's free to use also for commercial purposes. It is actively maintained. Latest stable release came out earlier this year. There is a new beta now coming up. with some nice new features. And this thing was founded in 2013, actually, by Java champion Gunnar Morling. This year, Philip took over, but there are some other people involved. Actually, I just spoke to Shaq, who I only knew by name because I have been tracking MapStruct for a while, but he was in the room with the Bold.com talk that also mentioned MapStruct. He might be in this room, so if you have really technical questions, I don't know, I'll just refer you to him. Now I have 16 minutes and I want to do a demo, so let's go to some code. If you want to check out the code, it's on my GitHub under Kuipers MapStruct demo. Separate commits there. Also, I did actually once try this talk to practice it, and it turned out I created a 25-minute talk. So I'm not actually going to do all of the typing myself. I will be quickly going over some prepared commits. Now, what do we have? I was as inspired as the previous speaker was to come up with some demos. So we have a talk with a speaker, and what I'm going to do is I'm going to map that talk with the speaker to a talk DTO with a speaker DTO. So what we have a name, we have a speaker, we have a duration minutes. Right now, as you can see, these fields are exactly the same thing. And without showing you, I can tell you the same thing is true for the speaker object that I have. What we have is an interface here, which is called a talk mapper, which is annotated with this @mapper annotation. Just checking here to see if the font is big enough, but it looks okay, I think. So what we do is we simply create a method here to say we want to have a method, and you can use any name for this method, that maps the talk to the talk DTO. So what we do now is we run the compiler. I will show you in a moment what I have in my Maven POM, but basically we've just specified that we want to use MapStruct as an annotation processor to the compiler plugin. And then what happens is code is being generated for me. So I can jump to this code, and you can see it over here. There is a talk mapper impl now. This is what it creates by default. You can also ask it to create something that has a Spring component annotation or that supports CDI if you want to use dependency injection, but I'm skipping that for this talk. So what you can see here is null safe, right? If I pass in null, it will just return null, and otherwise it will create this DTO and it will just copy over the properties exactly like you would expect. Nothing fancy there. Now, let's make it more interesting. Let's say we're going to map onto this talk DTO object, and I'm going to add a property there. So what I'm going to do is say, well, I want to have a room, right? Where is this talk being held? So we're going to have a room, because I'm not using Lombok. I'm actually going to create a getter and a setter. There we go. And now I'm going to run compile again. Now in this case, I'm mapping onto a thing that has a room, but my talk itself doesn't have anything like room. And in this case, it works. But if I scroll up a bit, there is actually a warning here from the compiler that says, hey, there's a non-mapped target property room. So right now, this is just a warning. For our use case, I don't want this to be just a warning. I want this to be a compile time error. Either I explicitly ignore this thing, or it should be an error. And that's exactly what you can do with something like MapStruct. Because here in the Maven POM, let me make that a bit bigger, we can see that I have the compiler plugin here. I have configured MapStruct as an annotation processor tool, but I have commented out some stuff that I am going to comment in. To say I want the unmapped target policy here to be set to error. The effect of this is that whenever there is something that cannot be mapped onto, and I haven't explicitly told MapStruct to just ignore it, it will create an error. So let's clean just to make sure, and then do a compile. And what we should see now is that I'm actually getting a compile time error where it says, well, there's an unmapped property there. So I can do a number of things here, and actually this is IDE support. I could just say I want to ignore this. So I can use an add mapping annotation and say, well, that room, that's okay. I'm never going to populate that, so just ignore that. But I actually don't want to do that here. So what I'm going to do instead is I'm going to go over to the talk and say, I need something to map onto the room, but I'm not going to call it room as well. I'm going to call it location. So it's a different name, but it's a compatible type in terms of the properties that we have. I'm going to add a getter and a setter for that one as well. And now what I need to do, obviously, is tell MapStruct, okay, so how do I know that I need to map from location onto room? So what we can do there is go back to the interface here, and then instead of saying ignore is true, I'm going to just say, okay, I want to have the source set from, in this case, location. Now, again, there is code assist here because I have an IDE plugin. So I can just control space my way through this stuff, which is super useful because I am very bad at typing, actually. So what we can do now is we can run compile again. And what we should see is that a new method is now being implemented. And as soon as it's there, I can take you to that code. There we go. And you can see that set room is now called by calling getLocation on the other thing. Next thing I want to show you is, let's say that we're not just mapping strings onto strings, right? Just compatible stuff. But I'm going to turn that location into a custom type. And this, again, I'm just going to do like this. So what we have now is we now have a location type. And this is a wrapper around the string at the moment, but location might have other stuff, right? Maybe there is a URL there because it might be a virtual talk, whatever. So what we now have is my demo code creates this location, and now I want to map that still onto a string room. So how would I do that? So in this case, it's actually very trivial because MapStruct allows nested bean property access using a dot syntax, right? So in this case, and again, there is code assist for this, I can just say, take the location name and map it. But what you will see is that if I generate code for this, it's still type safe. If I'm null safe, I mean, sorry. So if there is no location, it's not going to produce a null pointer exception saying, hey, I'm trying to get the name property from null. No, it will all be just null safe, and it will just work as you would expect. So that's really nice. Let's see what's next. Yeah, MapStruct can also map enum values onto values of different enums with similar values, which is a really nice property. So what we have here is our DTO now has a type, which is the type of talk. So it could be a bite-sized talk, it could be a regular talk, it could be a workshop. And I have exactly the same thing right now in my talk over here. This will work. I'm not actually going to demo it because that takes time of our precious 60 minutes, but it will just work. More interesting, of course, is what happens when these things are not exactly the same. So let's say I want to map onto other. But I don't actually want to say, oh yeah, right now I removed the workshop, so only workshop should be mapped onto other. No, every enum value from talk that does not have a corresponding one-to-one mapping, that should just be mapped onto other, right? So for this, there is actually something called a value mapping that we can use. And let's see. I'm just gonna not type it in to make sure that we stay on track. So that looks like this. What we see now is that I have a new method, again, name could be anything, that maps from the one type enum onto the other type enum. But I use the value mapping to say, oh, actually this is the old example, so let me just tune this, sorry. What I'm gonna say is, everything that is not mapped after doing the things that do actually have a corresponding value, so that's called any remaining, that should be mapped onto other. And if I now create my code again, because this one I want to actually show you, sorry, test you do it as well. I'm going to go over to the implementation, and what you will then see is that MapStruct generates again exactly the code that you would expect, because what it does now is it says, okay, case of byte size, I should make this a bit smaller for you. I'm going to map it onto byte size. Case of regular, I'm going to map it onto regular. Everything else is just going to map onto other, right? So before it would actually throw an illegal argument exception if it would have something that it couldn't map. But right now, because we used any remaining, it will map onto this. Quite useful. The next thing I want to show you is that I'm going to go over to my talk now, which had I'm going to go over to my speaker. And let me first show you the speaker. The speaker right now is a Twitter URL. And this is just a string. And it's mapped onto another string in the speaker DTO. So it's a one-to-one mapping. I don't really like the idea of my domain model modeling a URL as a string. So I'm going to change that into a URI. And I'm going to do that again by using Git, so that my demo code is also updated. That actually invokes all of this stuff. So now there's a URI. MapStruct by itself doesn't know how to map a string, URI, I mean, onto a string. So if I would now try to compile my code again, I will actually get an error. And the error says, I don't know how to do this. Now, what we can do is we can simply tell MapStruct how to do this by implementing a mapping method ourselves. Now, I'm in an interface in this case. MapStruct also supports abstract classes, but in this case, I'm already in an interface. So what I'm going to do is I'm going to add a default method. And here, let me just show you the result for that by doing this, because again, it saves me a couple of seconds typing. And you can see I now implemented a default string from URI that just says, okay, if the thing is null, I'm returning null. Otherwise, I'll just call toString on URI, right? That's one way of turning a URI into a string. Doing this, and then compiling my code will automatically ensure that the generated code from MapStruct now calls my mapping method whenever it needs to map the speaker's URL. So if we go to the generated code, what we can see here is that talk is being mapped. Then as part of mapping the talk, it maps the speaker, because by default, MapStruct actually does like a deep mapping. And in the speaker, we can now see that when it needs to set the string-based Twitter URL on the DTO, it will actually call our from URI method that is currently defined as a default method. Now, in this case, this makes sense because I just have this super small demo. But let's say I have a big application with a lot of different mappers. Maybe I want to actually make sure that all of the mappers now know how to map a URI onto a string. So I don't really want to specify this in the interface. What I could do then, I can actually extract this into a separate mapper that is a shared mapper. So that's exactly what I'm doing right here. And what you can see then is that we now have a mapper. Just to show you that we can, I've created an abstract class for this one instead of an interface. We have our same from URI method here, and the mapper annotation, obviously. But now, on the talk mapper side, what we can do is we can use the users attribute here of the mapper annotation to say, I just want to make sure that I can use this mapper, and then everything will just happen. Because what will happen right now, if I generate the code, is the implementation will just look up the shared mapper. By the way, in terms of looking up a mapper, right now I'm just using a static lookup method for that. And then MapStruct will just use naming convention, says, oh, there must be an impl class, and I'm going to load that. If you say I want to use something like Spring, it will just create Spring Beans for you that can be components again, and you can just use dependency injection instead. But for the purpose of this talk, it didn't seem really necessary to include Spring as well. So what else? Let's say our talk currently has a duration in minutes. I don't really like that, right? Java has a duration type. So what I want to do is I want to actually change that. So let me show you that. If I go to my talk now, you can see that right now there is a duration, but I still want to map that onto a field duration in minutes on the DTO side. Now this is not a generic mapping. This is not a generic type mapping where we say we always want to go from duration to int or long in this way. This is actually super specific for this one field. There's a number of ways actually that you can do this, and I want to show you two. First of all, what we can do is we can use a so-called expression. Here, I'm just going to inline some Java code, basically. So what we say here is, oh yeah, as part of doing the mapping to the DTO, whenever you need to map onto the duration in minutes, just take the duration. If it's null, it's null. Otherwise, we will call the Java 2 minutes method on the duration, because that's actually something that Java provides out of the box. Because of the tooling support, because of the IDE support, actually, even though this is, of course, just a string-based annotation attribute, I do actually get full support here, right? I can start typing and say, oh yeah, nice, there's this 2 minutes method. This ends up in the code. So you might actually get the sort of a bad taste in your mouth when you see people writing Java code in annotations, but this is all type safe because it will be checked at compile time, right? This is not like an expression language that will be evaluated at runtime and then blows up at the worst possible moment, so that's nice. However, I can see that maybe you don't like actually this approach, so there is another approach. What we can also tell MapStruct is say, well, just ignore the duration in minutes as part of the generated mapping. And then I'm going to have an after mapping. And in the after mapping, I will just say, this is how that needs to be mapped onto that. Or I can do some other post-processing, basically. But it's also super nice for these sort of things. One more thing I want to show you, and I think I'm on time, is that MapStruct cannot only map onto newly created objects, it can also map onto existing objects. And there are some nice use cases for this. To do that, basically all you need to do is create a method that takes 2 parameters. And then, of course, you have to tell MapStruct which one is the target. So now what you can see here is that I have an update talk method, this line, that says take a talk, take an existing talk DTO, and then update the DTO based on what we have. Now, if I do this, and I try to actually compile this into working code, I will get an error from MapStruct, because there is no default mapping that MapStruct can generate for a talk onto a talk DTO for an update because, well, we have things like location and room, and there's all that other stuff that I fixed already. Now, what I could do is I could just copy over all of the add mapping annotations onto this method, and that would work, but it would be hideous, of course. So fortunately, I don't need to do that because MapStruct actually allows me to say, well, I just want to inherit the configuration from the method with the compatible types and just apply that one. So I can do that. And now when I actually try to do my compile again, you will see that it works. And not only will you see that my compile succeeds, but I can show you the generated code. And then from that, you can see that indeed things like set room, taking the talk location name, all of that is just in place. You can also do things like inverse mappings. So maybe I just don't only want to go from DTOs. I want to go from domain to DTOs. I want to go from DTO to domain as well. Then there is an inherit inverse mapping, right? So all of that stuff is in place. Some other functionality that I'm not going to demo, you can have multiple source objects mapped onto a single target, right? It can just extract matching properties from multiple sources and then bring that onto a single thing. In the upcoming beta, or the current beta of the upcoming release, I should say, there's also support for mapping things like subtypes automatically. So we're actually really happy with MapStruct. It saves us a lot of time. It gives us compile time safety for things like changes in OpenAPI specs, which feels like super supportive, right? If someone adds or makes a typo maybe in an OpenAPI spec, we will actually get a compile time error, which I think is great. So definitely recommend you to give this a try, right? It's literally just a single dependency that you add. Doesn't conflict with anything, and it basically just works. That was my talk. Thank you for listening, and on to the next speaker.